Hello IBM, this is Sarunan from VETRI College of Engineering Technology. So this project was submitted by Sarunan, Kabilan and Soumya and mentor guided by Mrs. Manipriya, Assistant Professor of CSE. So our project title is Automated Weather Classification using Convolutional Neural Network Domain Artificial Intelligence. Abstraction. This presentation discusses the use of convolutional neural network for the automated weather classification. The CNN not type of deep learning algorithm that are well suitable for image classifications tasks. The CNN architecture is planned to process a sky images and produce a binary classification of either cloudy or rainy conditions. The convolutional layers output will be used to identify the input images as overcast, rainy, or using the full linked layers. Introduction to our project. Weather classification is process of identifying the type of weather conditions from an image. This can be useful for variety of applications such as forecasting, disaster management, and agriculture. Traditional method for weather classification rely on human expert to manually analyze images. This can be time consuming and labor intensive, and it is also susceptible for human errors. So existing system, this is already existing system. We can overcome these problems into our project. The existing system for weather classification is based on human experts manually analyzing images. This system has several disadvantages, including it is time consuming and labor intensive, it is susceptible to human error, it is not scalable to large data sets. Existing system disadvantage. The training and operating of neural network like that are computationally expensive and demand a lot of memory and processing resources. The model could not work well in specific weather situations or geographical areas. It might be challenging to understand how the model generates its prediction. This may take it more difficult for forecasting to understand the finding and draw valid conclusion from the model's output. Proposed system. Creating a dataset of photographs of the sky in various weather conditions in a initial stages, constructing the system to ensure the all of photographs are the same size and format. The data will be pre-proposed. The training set will be used to train the CNN model, and the dataset will be divided into validation, testing, and training sets. A number of convolution layers will be collect the features from the input convolution layer. Output will be used to identify the input images as overcast or rainy using fully linked layers. The weight of the model will be optimized using backpropagation with binary cross entropy loss function during the training. The loss function will be minimized throughout training using RM optimizer to get the best performance the models. The hyperparameters such as learning rate, edge size, and number of epochs will be fine used to validation sets. The epochs are nothing but they are set of data to be trained at a particular space. To assess the visibility of the suggested methodology, and finding will be constructed with those obtained using the current cutting edge technique for weather conditions. Proposed system advantages. The algorithm detects cloudy or wet weather with excellent precision and recall, demonstrating its high level of accuracy. The adoption of the deep learning method, particularly CNN, the excels at the picture classification task, can be credited with its accuracy. The CNN architecture is appropriate for applications like the autonomous driving and air traffic management because it is quickly and effectively categorizes input images based on their relevant properties. Proposed system diagram. First of all, we can input the images into camera and then load into the PC or laptop. Then CNN weather directions. They are directed cloudy or rainy. Okay. So next, the CNN architecture diagram. The first of all, dataset, collect the dataset and train and test. The dataset can be pre-processed and go to max pooling layer, conventional layer, dense layer, flatten layer. The trained model can be saved as a model.h5 and JSON files. The model.json files can be tested with the new input images and predict the output. Flow diagram. Camera and testing and training. Then out go to CNN model and training the model, testing the model, then we get the output. Use case diagram. The first step you first use case of PC or laptop. The test images can be pre-processed and directions with the cloud or running. The classification using CNN and predict the outcome. Activity diagram. First start procedure and test data and directed cloudy or rainy. Then stop. Model's description. The image dataset collections. The gathering all images. The download dataset from Gaggle website. Okay. The image pre-processing. It can be used for prepare the images by renaming, resizing and labeling them for train model. Train test validation. They split the dataset into two sets. One is training set and another is testing set. Data training. Data training is a data you use to train an algorithm or machine learning model to predict the outcome you design your model to predict. Test model. The machine learning model testing is referred to as process where the performance is fully trained model is evaluated in a testing set. Software requirements. OpenCV. It is used for image processing, deep learning model algorithm. We can use CNN techniques or any transfer learning algorithm. Operating system. Windows 10 or 11. Software tools Python 3.615. Processor Intel or AMD. RAM minimum 4 GB recommended. ROM 2 GB. The software requirements Python 3.615. TensorFlow, Keras, OpenCV, Pandas, NumPy, Pillow. They are Python models. It can be used for many of these image classifications. And then we can go to conclusion. In this conclusion, the suggestion CNN based system for cloudy or wet weather directions demonstrated promising results. The another crucial aspects of system is effectiveness and its ability to accurately and effectively manage massive amount of data. The proposed system resistance to diverse the weather conditions such as snowy or foggy circumstances may be improved in future work. The more classification of weather class circumstance such sunny or clear conditions. It can also add to the system. Then feature scope. The feature scope of the system project including the following: developing a more robust model that can classify the weather classifications images with even highly accuracy. The developing the mobile app that can be used to classify weather images and the integrating model with the weather forecasting system to provide the more accurate predictions. Source code. We can use our project. This is the source code. So we can train the images are as given and then final output. So I can input the images in our camera and that is predicted cloudy 77% and another images 86% with accuracy, and I can give the rainy images that can predict in 79% and rainy images predict 79%. The following left corner, the what images it is detected that can be printed. So this is the cloudy, rainy. They are printed in this section. So if any queries, and thank you IBM.